All right, what I'm going to do today is I'm going to try to prototype for myself an active high-pass filter. A high-pass filter is one that takes in a signal and allows the high-frequency band of that signal to pass and blocks the low frequencies. This is really good for pro audio stuff where you don't want to let any of the low frequencies through. So we're going to prototype this thing. We have the advantage of knowing in advance how to power with plus 22 and minus 22 volts. And I'm going to show again how that's set up. But in this assignment, I gave the initial setup right there. So I'm going to need apparently two power supplies, a frequency generator, various capacitors, resistors, capacitors, and an op-amp. Set the frequency generator to 10K with 0 offset and your scopes to 10 microseconds. I didn't see to mention here that you need oscilloscopes in order to see the signal. That might have been obvious, but I won't discount any points if I get circuits built that don't have any scopes in. And when you finished, upload a screenshot of things. So what I need to do is start building this circuit based on this screenshot. I see a little bit of op-amp stuff that I recognize. I have the output coming through a resistor back to the input. I've got some resistors going to ground. I have a curious 3.6 ohm resistor there. But in particular, I've got my op-amp powered between 22 volts and negative 22 volts, and I've got a 10 kilohertz source. Of course, I have some capacitors in the circuit. Capacitors are how I created frequency blocking when we built our original discrete filters. So what I have to do now is go to Tinkercad and make this thing happen. So I'll go back and forth between my circuit diagram here and what I'm doing in Tinkercad. We see in Tinkercad, I've already got a lot of stuff set up here to save time in the video. I've got the basic setup for my op-amp. I've got a power supply here, which is supplying 22 volts. And I've got it connected black to black, red to red. Down here, I have a power supply, also 22 volts, but notice that I've got it red to black, black to red. This is what's giving me the negative 22 volts that I need on the downside of my op-amp. I've connected the two grounds together, common ground everywhere. And pardon me. To that end, I'm going to take my frequency generator here, and I'm just going to go ahead and connect it to ground, do things as neatly as I can, although I have to work somewhat quickly. I can rearrange these, make it look pleasing. So the frequency generator is connected to ground. Here's one of my scopes. I'm going to connect this scope to ground right there. Stretch that out a little bit, make it look nice. I'm going to connect this other scope to ground right there. That's fine. Connected to ground. Okay, so everything has the common ground. My op-amp is powered. See, this is the power plus terminal. There it is, connected to positive power. Here is the negative power terminal, and it's calculated, it's connected to the plus down here. But remember, that's negative 22 volts. So by doing that, I have my positive 22 volts and my negative 22 volts, and I'm good to go. Now, I just have to build the rest of this. So I like to go from input to output. So I'm going to start over here with my 10 kilohertz frequency generator, which one end of it's connected to ground, which I already did. And then I'm going to go from it into a 1 nanofarad capacitor. So here's my frequency generator. You see I've got it set for 10,000 hertz, which is 10 kilohertz. Over here, I'm going to place on the board a 1 nanofarad capacitance. See, capacitance is 1 nanofarad. I'm going to take the output from my frequency generator, and I'm going to run it right up here to the capacitor. Notice I didn't have to go all the way because all of these points are electrically connected, so that's going to work out just fine. That capacitor is immediately connected to another capacitor, so I'm going to take this second capacitor here and I'm going to overlap it like that Right? So now I've got this middle spot between the two capacitors, one capacitor, then another capacitor, then another capacitor. Between the two, I have a 33K running to the output of my op-amp. Well, the op-amp output is right here, over here on the circuit. So I got to get there from the middle of this group of, well, these two capacitors here. So I'm going to take a wire and I'm just going to scoot over here so that I can scoot up here, so that I can scoot from here over to the output, which I think is that one, yeah. So notice my path doesn't look like it's direct, but it really is. It goes from here to here, which is connected to here, and then to here, which these two are connected, and then over to the output. I skipped I skipped the resistor. So let me go ahead and delete that. I need a 33K resistor to be in here. So I've hooked the one end of the 33K to the output, and now I just need to get over here to this, like there we go. Now I'm good. From the center of the capacitors to the 33K, from the 33K into the output. So I just went over the top here, like that. Now I've got to go from the positive, the non-inverting input on my op-amp, the one that's labeled plus. I have to go through a 33K to ground. So first of all, let me find it. That's offset 1, that's not it. In negative, that's not it. There is the plus. I have to go through another 33K to ground. So I'm going to connect this 33K into the ground right there. See, it's selected in the black negative right there. And it's connected here, which goes to plus. So my plus terminal on my op-amp is indeed connected through a 33K to ground. I've now taken care of, wow, everything except this bit that goes under in these two resistors. So what I see here is I'm going from the negative terminal, the inverting terminal on the op-amp, and I'm going to through a 10K resistor to ground. So that's the first thing that I'll do. I have a 10K resistor right here, and I'm going to take that 10K resistor to ground. I'm going to do it, I guess I'm going to do it right here. Maybe that makes sense. And then from the negative terminal, see, this is the negative terminal on my op-amp. I'm going to go from the negative terminal right there to that, the top of that 10K. And so that'll get me to ground from there. Now, I need to go to the other side of the board now because or other side of my breadboard, like on the other side of the slot, because I'm now headed back to the output again with a 5.6K resistor. So I'm going to take my 5.6 and I'm going to drop it right in there. And you see all of this right here is all connected. I've got my 5.6 here. Now I've come over the top. I just have to get to the output. The output is this terminal right here. The output terminal right here. So I'm going to go from here to my resistor, and there you go. So I've created all of the connections, and I believe that I've done it appropriately. But now I need to be able to see if the thing is doing what it's supposed to do. So I'm going to take the from the positive output of my frequency generator. Well, I'm going to actually start over here at this scope. By the way, the scope I've set for 10 microseconds. They should adapt on their own, but I find it's useful just to go ahead and make it what it's supposed to be. And I'm going to come over here and do something a little bit surprising. I'm going to connect that to the output of my frequency generator. Oh, now I've messed it up. So I just back up a little bit. Or, back up all the way. That's another option that we have. To here, to here, to here. So it's connected. And there we go. Now, the reason why I've done that is that if I start the simulation now, no matter what my circuit's doing, my one oscilloscope is showing me the input signal. This is the signal that's going into the circuit. And now I need to scope the output signal to see what I'm getting. So I'm going to stop the simulation. And I'm going to connect my other oscilloscope, which, by the way, if I click on it, has the same time per division, 10 microseconds. And I'm going to connect the positive terminal of this thing. Where am I going to go with it? I need to connect to the output. And honestly, I can do that right here by connecting it there. And then I'm just going to jump from here to here. Even there's a lot of wire going on around here, but it's all connected to the output. So it's like all of these spots, they're all the same. So now when I start my simulation, I'll see my input on the right-hand scope and my output on the left-hand scope, and there you have it. Well, it's not exactly doing what I wanted it to do. Ha 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 ha. At first I thought, well, this is bad. This is what I'm expecting to see. I'm expecting to see my input signal here on the right-hand oscilloscope, and my output signal should be reduced because it is it's been filtered by 70%. So it should be smaller, and yet it looks bigger, but you can tell that the reason for that is this is 10 volts on this scale, and this is 100 nanovolts on this scale. So it has been reduced by the scale, but there's no way to set the vertical